And today's goal is to talk about the midterm exam, which is going to be next Tuesday. Midterm will be next Tuesday. I emailed you a practice exercise for the midterm. So that exercise is what I intend to look at today. So let us find it. I already found it here. So this exercise has a question about various stages from chapter 2. So I designed the student ID here for you. So some kind of 1, 2, 3, 4, 5, 6 number that ends with a 6. That's a I think we should have it a little sooner than that, because we should not accumulate too much of information on it. In fact, I know you're looking at the syllabus, it's a tentative schedule. Tentative means approximate, right? The approximate. So I'm thinking that we should not postpone it till another 2 weeks, because otherwise it might be a little bit too much of material. So that's why I think that Tuesday will be a good idea to run the midterm. And I already sent you the exam, the practice exam. So if we wait another 2 weeks, well, people forget things. That's one issue. The other, that some of you emailed to me, that recordings of lectures, they disappear. You probably noticed that 30 days is what Zoom keeps these recordings for 30 days, and then I think they delete them automatically, so I don't have a control over it. So if we wait more time, well, I guess we'll have less recordings. And since I plan to give you the midterm on chapters 2 and 3, then entire chapter 2 will disappear. So I don't think it's a very good idea. So we're dealing with completely different textbook. And that's why this syllabus story is not going to be what we use for this class, because there used to be another edition of textbook that I utilized and that actually disappeared. So the answer to your question, do you have to do sections that are not covered in class? Of course not. I don't expect you to do any problems that we didn't work on together. So section 3.7 is something I'm going to leave out for now. So we're going to stop at 3.5. So let me list sections that we should do for the homework. That'd be chapter 2 and chapter 3. So in the chapter 2, we looked at the sections from 2.2 through 2.6 here. And then in chapter 3, we looked at sections 3.2 through 3.5. So I would say this is a good chunk of material for the midterm. And then we will continue with the other sections of the textbook. I think this edition author crunched 2 chapters into 1. So that's why we actually covered not first 3, but first 4 chapters. And I think first 4 chapters is plenty for the midterm exam. because this edition of textbook is a little bit more compact than the one that we utilized before. So please don't look at the sections. The reason is I noticed that old edition of the textbook that used to be online for free disappeared, but this edition that we're using right now appeared. And that's why I didn't have time to change those chapters. So you don't need to worry about these things because material is the same. It's just a different layout from one edition to the other edition of this same exact textbook. But of course, the author cannot just keep exactly the same identical textbook and call it, instead of 9th edition, 10th edition. So they start to reshuffle various chapters and sections as much as they can. And that's really what it is. So I hope you received the email that I sent to you yesterday. And this email has a practice midterm attachment to it. So I will give you the actual midterm in exact same format. I'm going to email to you another PDF file. So you just click on it and see two problems rather than just one that I put in here. So today I intend to work out this exercise for you. And in order to make this different in terms of the answer for different students in our class, because if we basically have take-home exams, so to give the same answers for entire class would not really a good idea. So I utilize last digits of student ID in order to make sure you don't get the same answer. The problems are the same, but the answer should be a little bit different. And that's why I use like last digit, I made up like 6. So this way, in that particular sample, you will not have B, but number 6. So I can work out these exercises with last digit 6 here. Or if someone wants me to put some other last digit, you just tell me which one, which number you want me to put there, so I can replace, instead of 6, put some other number. Turns out it doesn't really matter. But of course, the answers are not going to be identical. And what I have to do now is to rearrange those elements of the sample in order from smallest to the largest. So this way I could find such things as median and so forth. So those are the ones that we see as question to among these little exercises. So I know that this is a little bit annoying, so I think that I will give you for the midterm exam the better looking sample that will be already nicely rearranged for you, because it looks like it's a little bit too much, right, to rearrange those. Some people may not like this process. So 3, yes, you're welcome. I think you don't need to waste your time doing other things, but just to concentrate on the actual statistics part instead of doing some kind of rearrangements. Let me see what else here. 3.7 appears twice, right? Please help me if I miss some of these pieces of data, but I think there's 3.7 and then another 3.7, and then we have 3.9 here. Oh, there's 3.8 also, and then 3.9. See, when I give you a ranged sample, you're not going to have to worry about this stage, so you don't waste your energy on doing some other stuff. So there's also element 4.0 here. and then it's friend 4.1. So I'll give you a nicer sample. I guess I created this one for myself just for fun, but you will get on the exam something much nicer. 4.9, then we have 5. Looks like there is a 5.1 and then 5.2. Well, the good news is that we're coming to an end of this rearrangement pretty soon, so it's already nicer. Nice thing to know. 5.5. Oh, there is one more 5.1 here. How about that? Let me squeeze it in here. 5.1. So you need to be very concentrated. And then 5.2. And then there is a 5.5, right? Oh, there is also 5.3. I just saw 5.3 and then 5.5. Okay. Well, we're almost done. That's good news. 5.5. Now there is no more, but remember there is element 6 that I have coming from my last digit of student ID that was created. So that 6 is here. Now, if your last element of student ID is 0, then, well, you put 0, it'd be in front. And if it's something else like 9, well, then put 9. So it will make your answer definitely not identical. It'd be very similar, but not identical with the other students. So let's see, 2, 4, 6, 8, 10, 2, 4, 6, 8, 21. Okay, 21 sample elements. So that's a good start. We now gonna see what they're asking us here. And in the part 1 of this exercise, they want to know standard deviation, which is a calculator exercise. So all I do is just copy all these sample elements, of course, without letter B. I'll put 6 in it. So I copy this and enter into standard deviation calculator. So let me type this. Standard deviation calculator. Notice it's choice 1. Because not many people are searching for standard deviation. So there's calculators here. So I will click on it. Remember, there was a special calculator that wants commas in between. So I copy and paste all of these sample elements, and now I need to put commas in between. Well, it's great that I can nicely copy and paste these sample elements here. And of course, I should not forget about 6 or whatever your last digit of student ID is, right? That does make a little difference. Be pretty close, but still will make a little bit of a difference. Okay, so I just need to put a few more commas. And advice is do this simultaneously with me, because this way you are preparing for this midterm exam question. So if I put 6 and then comma in front, make sure that you click sample and click calculate, so you will get yourself a nice answer. So it looks like standard deviation is 2.6 and so forth, 0, 3, 5, 5, dot, dot, dot. So I put a few digits, dot, 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 that's fine. So question number 1 is here, pure calculator exercise. Question number 2 is another old favorite that asks about mode for the sample. And looks like I have more than one mode here. In fact, I have 3 of them. Look at them. 1.8 and 3.7, and also 5.1 appear twice. So these 3 elements will be my modes. There are 3 of them. Well, mode is another part. Now we need to get a stem plot or stem and leaf display. So for that matter, I need to produce a stem and leaf. So I put a vertical bar, not slant as that, like that. For the stem, notice that arranging the sample was very helpful, so I can see first digits of my elements, such as 1, 2, 3, all the way 6, 7, 8, 9. Now notice that I'm going to put decimal part in the leaf, so I need to keep going until 13. So it'll be 10, 11, 12, and finally 13. So for the leaf, I put those decimals, so 0.8, 0.8, 0.9. So I've got first 3. Next will be 2.4. There is only one with a first digit 2. Now 3.1, 4, 4, and then we have actually only 1 4, 2 7s, not 2 4s. I should be careful. And I have to arrange them in such a way they align from the top to the bottom. So this way I can compare and see that my class with a 3 definitely has more elements than class with 1. So I put these digits one under the other. So analogously with the following, so 40, so like 4.0, and then 4.1. So I put digits carefully underneath, and 4.9. Then we have 5s. So there is a couple of 1s. And then there is a 2 and 3, like that. And we also have 5.5. Okay, so that's the last 5. So I can see with this alignment that class with a 3 has a little bit more in it than with a 5. Now 6.0, so I put 0 here, 8.3, and also 13.7, so put 7. So it looks like that 13.7 is pretty far away, but that's, well, could be an outlier. So I produce so-called stem plot, or sometimes they call it as a stem and leaf display. Next question is in producing the ogive. And for that matter, I need to break my sample in 4 classes. And that's actually what the exercise is telling us. So we have to break our sample into 4 classes, pretty much equal ones. So my sample starts with 1.8 and it ends with 13.7, right? So I need to find so-called class width by breaking into 4 classes my range. So since I have 4 classes, I need to take a range which is 13.7, the largest, and 1.8, the smallest. So when I subtract this, it'd be approximately like 12 divided by 4, which is 3. Remember, we're always trying to make it look as nice as possible, which means that I will rather use whole numbers for these ranges instead of some decimals, because otherwise the boundaries will not be as nice. So if I move by 1.8, by 3 from 1.8, we'll get to 4.8. And if we move again, we'll get to 7.8. And again, we'll get to 10.8. So notice that adding 3 is definitely much nicer than adding some nasty looking decimal. So now I'm gonna create a little table here and think about classes. So put class in this table. So we'll have first class, which is starting at 1.8. Second class will start at 4.8. Then we'll have class number 3 that goes from 7. And finally, class number 4 that goes from 10.8. Looks like I kind of trying to save room. Maybe I'll just put it like that so it doesn't disturb us. So last class will end at 13.7. So this is my last element of the sample. I think I should make it a little bit bigger so you can better see. This is hard to see, so it's no good. So 13.7 like that. Okay. So then my class before will end at 10.7 because it should not touch the last class. So classes need to be non-overlapping. So I need to carefully put my last point of the class. So it'll be 4.7 here. And we produce the boundaries for our classes. So now it's time to get so-called frequencies or number of elements in each class. And to get these frequencies, I'll just see how many we have in first and second and so forth in all of these classes. So my first class ends at 4.8, so it goes all the way up to here. So there'll be lots of elements, 4, 6, 8, 10, 12. Okay, so I put 12. Next class goes up to 7.7, so it has pretty much everything else, including 6. So that's 2, 4, 6, 7 elements. Then we have only one element in the next class and one more in the last class. So please notice if I add all of these numbers together, I will produce 21, which is exactly my sample size. That means that I did not miss any elements or didn't count any element of my sample twice. So finally, I need to get that cumulative frequency. So I need to add frequencies together. So the first is 12. I keep it unchanged because before 12, there is nothing I can add with it. For the next one, I add 7 to the previous, to 12, and etc. So now I add this new number 19 with 1 that sits here. I get 20, and finally put another 1 on the top of that 20 and end up with my sample size n, which is 21 here. So now I'm going to put the points here on the picture. And for convenience, I'm going to have that 21, the largest number here, with a dot at the very, very end of my last class. Because now with respect to 21, I want to put the rest, such as a first frequency, which is 12. It's more than a half. It should be someplace up here. So this is a point that corresponds again to the end of my first class. So always point at the end. Then next will be 19. Well, it's almost 21. So it's almost on the very top. So that's for the next class. That's like someplace up here. And finally, right in between will be another little point. Connect them and produce that ogive. So I connect these points with straight line segments. Make sure that I start at the x-axis. And this graph is called ogive or cumulative frequencies diagram, and that's exactly what this part of exercise wants. So it is technical, and the advice is redo this on your own with your own last digit of student ID. That'd be a great practice. So now, final part of this exercise is in finding those outliers. Box plot, in other words. So you have to have first quartile as well as a third quartile. And then based on those, I will be able to put fences, and whatever falls beyond those fences will be called as my outliers. So I need to know what is Q1 and what is Q3. Those are key numbers for us in this sample. So we find a range in between those first quartile, which is 25% of sample size, as well as a third quartile, which is 75% of sample size. So I would recommend you to take the calculator and put those numbers in it, so you can just calculate 0.20. I know it's kind of hard to see here, but try to put it on your calculator. So you get 5.25. Looks like I have here 5.25. And analogously, you will get 75% of this. So you can just put 0.75 and multiply it by sample size 21. So it'll be 1575. So these two numbers are both decimals. So when I encounter decimals, there is a standard procedure that we do. We move to the next position. So from this decimal, I move to the place number 16. And from that decimal, I move to the place number 6. So next position. So what sits on this position will be my quartile. So in my case, on the 6th position, we have 3.4. So I call it as a first quartile, whatever sits there. But sample has to be arranged. 8, 10, 12, 14, 16 position is right here, 5.2. So I must arrange sample, and then I take those quartile. So for the decimals, we always round because we don't have in our sample element with a decimal position. Position here I have is position number 6, and position there is a position number 16. So just take element that sits on those positions. So that's important. So now I have to see how wide my box is. In other words, what's the interquartile range? So I know that it starts at 5.25 and that it ends at, it starts at 3.4. It should be careful. Element samples 3.4, and then it ends at the sample element 5.2. So gap in between all these two numbers is called range in between those two quartiles. So you just subtract these and produce 1.8. So that's an interquartile range that I must multiply by 1.5. That was the rule to get that very important number for our exercise, right? So when I multiply this, I get 2.7. I can put this in a calculator, make sure that I did it right. So I think it's 2.7. And this way, we now can see by how much we have to move to the right 2 times to produce those fences, as well as to the left from the other side of the box and produce those fences. So what I have to do is move by number 2.7. So that's the key number for us now. So I have to take 5.2 number here, quartile 3, so on the right side, and add to it 2.7. So I bring myself that much to the right, so it's going to be something like 7.9, and put my first fence here. And then I do the same thing once again. So I add 2.7 to 7.9, because we're moving to the right, so we add, and this gives us something like 10.6. So I produce two very important numbers. We put fences in this exercise. So this is so-called definition. Definition means they told us this and we remembered. So it came from the book. It's a definition. So we define this. That's where it comes from. So I guess that's what we have to be aware of. And that 1.5 is always going to be our 1.5. So by the way, it's actually 1.8. You're right, not 1.9. I just miswrote it. So whatever number I produced for interquartile range, it's 1.8. I multiply by 1.5. And I got 2.7. I just wasn't careful. I should have wrote 1.8. So analogously, I go to the other side to put more fences. So now I start here at Q1, which is 3.4, and I go to the left. So I must subtract this same 2.7. So I subtract it once, and then I subtract it once again. So I produce 0.7, and once again, I subtract that same 2.7. So this becomes a negative 3.4. So there's two places. Once again, I'm going to have to stick my fences into. And now we're pretty much done. All this tedious and lengthy procedure is almost over, because all we do this for is to identify the outliers. So we start on the left side of the sample. We see the lowest element, which is 1.8. This 1.8 is fine because it sits in between of 0.7 and 3.4. So 1.8, another 1.8, 1.924, they will just get closer and closer, so they're not beyond my fences. And that's why I need to go on the other side where I see the largest element, or 13.7, and compared to 10.6, this 13.7 is beyond your fence. So that's why it's called as extreme outlier, because it's beyond your fence that sits on the outside. So extreme outlier was identified, and that's the question that exercise 5, part 5, actually posts for us here. Identify, so not just say outlier, but is this an extreme outlier, or what other type of outlier? So let me look at the element next to it, which is 8.3. And notice that 8.3 is here someplace, isn't it? 8.3 is also beyond the fence. It's actually beyond one end prior to the previous. That's why it's called mild outlier. So there is a extreme outlier in this sample, and there is also a mild outlier, element 8.3. So if you decide to calculate something related to this sample, well, then you should probably throw away this outlier, so your answer is going to be more precise. Because notice that element 13.7 is really too far away, as well as 8.3 is kind of too far away from majority of elements in your sample. And we actually were able to say for sure that they are outliers. So we have identified those. So sometimes we have outliers in the sample, sometimes we don't. So it's not that automatically we get those outliers. So one should be aware of it. So now next element in this sample here, the element 6 that I have from the student ID is actually fine because 6 will be someplace here. So 6 is already within the range. 6 is not beyond my fences. So it means that we don't have any more outliers here. We have found 2 of them. So please try to redo this same exercise again sometime, maybe tomorrow or over weekend, because that will prepare you pretty well for the first exercise in this midterm exam. And now I'm going to talk about the second exercise. I know it might be a little bit too much, but I'll just tell you what problems to look at to prepare for the second exercise. And next time, if you want me to, on Thursday, when we continue with our review for the midterm, so next time I can do it for you. So it'll be a good idea. I think that you try it first, because then you will feel way, way more familiar and comfortable with this. So I made a recording of this. So if you need this again, it will be on the recording of lecture that I will email to you in an hour or so, as soon as it gets available. Because sometimes people ask me, Alex, so where is the recording? Well, you should ask Zoom, because as soon as Zoom converts this video and audio file to the actual file that I can email to you, it takes a while. It takes more than an hour for some reason. So I will send it to you, of course. So you don't need to send me midterm practice, because that's exact same thing that I just did for you, right? Midterm practice. You don't have to send it to me. If you want to include it with your homework, then of course you can put it there as well. But just separately, you don't have to. But since you do it at home, yeah, you can include it with your homework. Why not? Maybe it's a very good idea. So homework are here. So those are sections that I already mentioned to you. And I told you to do a couple of problems from each section. So a couple means 2. So you can just select one and then another. And that should be good enough. If you have already done problems from these sections, you can send it to me right after class. So you will be done with that part. You just need to make pictures and attach those pictures to your email and send it to my school email, that mdc.edu, that email that I have in syllabus, that email that I just sent you this midterm practice from. That's the only place where I want you to send me your work. So don't start sending it just about anywhere and to anyone. Just send it to me, to my school email. Okay, so let me take a look at section 3.5. So the other problem will come from section 3.5, which is the last section of chapter 3. I will show you a couple of exercises that you should try to do to better prepare to this. So it's page 150. So to get to that page, I need to put like 180 or so at 30, right? A little bit too much. So let me go back a little bit. So maybe at 25 is what I need or something. So the question, so maybe I can clean this because it's just way too messy. stop sharing this and share this again so you can better see the screen. So we looked at section 3.5 in quite detail. So I think if you look at these two problems before Thursday, that'd be a great idea. And then I can do them for you on Thursday. So something very, very similar to this will appear on the midterm. So at least you know the wording. So just different numbers. You already know numbers are not going to be the same because they depend on your last digits of student ID, right? That's why they're not identical. But other than that, they'll be pretty much the same. Yeah, you can do a couple of problems from each section that we covered in class so far. Make pictures of them, of those homework, and send it to me by email. So as soon as you're done, you can send it to me by email. The due date will be next Tuesday when we have a midterm exam. So try to do it over weekend if you're not done it so far. So just take your time, do these problems. You don't have to do them perfectly fine. You could just at least start. If you have no idea how to do them, check out recordings of lectures. I record lectures, right? I email you those recordings. So you can open these recording files and you will see how I did problems from this section. So you can just do same exact exercises because I don't tell you which problems exactly to do. I recommend to do odd problems, but if you want to do some others, that's fine. Just do something, send it to me. You will get a full credit for it for the homework. So that's pretty much all I wanted to actually say today about the midterm and preparation to it. So I'm going to stop the recording.